Welcome to the Deep Dive.
Good to be diving in.
Today we're tackling something I know has sparked a lot of curiosity for you listeners. The increasingly tight link between the natural sciences and ethics.
Yeah, it feels like almost every big scientific step forward brings a wave of moral questions with it.
It really does.
Yeah.
And you've asked for a way to get your head around this complex relationship quickly. So that's our goal today.
That's right. We've sifted through quite a bit, including a really insightful article, The Natural Sciences and Ethics, from benchtop breakthroughs to planetary policy. And it really flips the script, suggesting ethics isn't, a separate thing we think about after the science. It's baked in.
Exactly. So our mission today, unpack this evolving dynamic. We want to highlight the key tensions and give you a framework for understanding this critical intersection. Ready?
Let's do it.
Okay, so where do we start? This idea that ethics isn't just an add-on.
Well, the source material kicks off right there. It contrasts this old idea, the value-free ideal of science.
Pure objectivity, just the facts.
Exactly that idea. Contrasts it with what we actually see, which is more of a value-saturated practice.
Okay, so values are already involved. How?
It's in the choices scientists make, even seemingly neutral ones.
Like what kind of choices?
Like, even just choosing what questions to ask.
How so?
So the article gives the example of climate modelers. They're increasingly putting out these loss and damage maps.
Okay, showing potential economic impacts.
Right. Quantifying future harm. Now, that's scientific data, sure, but by focusing on loss and damage, the field is shifting.
Shifting towards
Outputs that are really centered on fairness, on justice, who gets hit hardest. That wasn't always the main focus. Maybe earlier models were more purely predictive.
Ah, I see. So societal priorities, like fairness, are influencing the direction of the research itself.
Precisely. It's about what we as a society deem important to investigate.
Okay, that makes sense for choosing questions. What about, the actual doing of the science, the methods?
Ethics plays a huge role there, too. Think about the COVID-19 vaccine trials.
Right, they were fast.
Super fast.
Right.
And that rolling review process regulators used, where they looked at data basically in real time, that was a clear ethical trade-off. Speed versus certainty.
Get the vaccine out quickly, but maybe with less long-term data initially.
Exactly. How much risk you tolerate for speed, that's fundamentally an ethical judgment, not just a scientific one.
And then, okay, let's say you have the breakthrough, like the vaccine.
Yeah.
It doesn't stop there, right?
Yeah.
Getting it to people?
Absolutely not. And that's another ethical minefield. The article points to the huge gap in vaccine access.
Yeah, the difference between richer and poorer countries was stark.
Very stark. By early 2025, something like only 30% in low-income countries had the initial shots, even with COVAX trying to help.
Wow.
So it shows, a neutral scientific discovery can actually make inequality worse depending on how it's distributed.
The science is one thing. The real-world impact is another.
Completely.
Okay, this feels like a good transition to something that sources really dig into.
Yeah.
These dual-use dilemmas.
Ah, yes. The tricky question of whether all knowledge is actually worth pursuing.
Especially if it could be used to cause harm, right?
Exactly. Gain-of-function research in virology is a prime example.
Where scientists modify viruses to understand them better.
Correct. The U.S. paused funding for that between 2014 and 2017 because of safety worries.
Right, I remember that debate.
And even when it restarted with new safety rules, the debate flared up again in 2024 over H5N1 bird flu studies in ferrets.
So the core tension is potential knowledge versus potential danger.
Precisely. Does understanding the threat outweigh the risk of creating it or letting it escape? It's a constant balancing act.
And it's not just biology anymore, is it? AI is crashing this party too.
Oh, absolutely. That 2024 RAND simulation, that was pretty chilling.
What did it show?
It showed how easily available open-source AI language models could potentially help someone plan a bioweapon attack.
Yikes, okay.
Yeah. And that led to immediate calls for, maybe licensing or regulating the most powerful AI models.
Because the same tool that can write poetry could help plan something terrible.
The classic dual-use problem, just in a new technological wrapper.
Then there's something that sounds maybe less immediately scary, but is still ethically complex. The Mars sample return.
Right. Bringing bits of Mars back to Earth.
Seems like pure exploration, but there are risks.
Definitely. NASA added an extra step in 2024 in-flight UV sterilization to its whole capture, contain, return system.
Why? Martian microbes.
Exactly. The ethical concern is planetary protection. How do we make absolutely sure we don't accidentally contaminate Earth with something from Mars?
And the safety measures get really complex, really expensive.
Incredibly so, which brings up that great question the article poses.
Let me guess. Who decides when the cost of safety outweighs the quest for knowledge?
You got it. When protective measures become as costly as the research itself, who decides the acceptable balance of risk and curiosity? It's a tough one.
It really is, and it pushes back against that idea of science just being about objective facts. The facts themselves seem to force these value judgments.
That's the core argument the source makes against the myth of pure objectivity. The facts trigger ethical decisions.
Okay, give me an example there.
CRISPR gene therapy. Casgevy, for instance. FDA approved in 2023 for sickle cell. Amazing science.
Truly life-changing potential.
Absolutely. But the price tag? Around $2 million per dose.
Whoa. Oh, okay.
So the immediate ethical question isn't about the science working. It's about justice and access. Who gets this cure?
So a scientific win doesn't mean a societal win if hardly anyone can afford it.
Exactly. Or think about AI climate models. They predict we'll hit 1.5 degrees warming by, say, the late 2030s. That's the science bit.
Okay, the projection.
But the decision on whether to deploy something like solar geoengineering blocking sunlight to cool the planet, that's not an empirical question anymore. That's a massive ethical choice with global consequences. Science tells us what might happen, not whether we should intervene like that.
And this even applies in less dramatic areas, like lab animal research.
Developing biomarkers to, say, measure stress in lab mice seems purely technical, more objective data.
Right.
But ultimately, someone, usually legislators, still has to decide what level of suffering is acceptable. And that threshold isn't scientific. It's based on societal values about animal welfare.
Which brings us neatly to those moments where science really bumps up against deeply held beliefs or norms in society.
Yeah, those moments often generate the most heat.
Like the CRISPR-babies incident.
Exactly. Jiankui in 2018 editing human embryos that were brought to term, that caused a global uproar.
Because it crossed a line for many people, messing with the human germline.
Right. It challenged fundamental norms.
Yeah.
And you see the reaction. The WHO in 2024 calling for global rules and licensing before anyone attempts heritable editing again.
So a case of the science maybe getting ahead of the ethical consensus.
Way ahead. And we see similar tensions with synthetic embryo models, or SEMs.
The ones grown from stem cells.
Yeah. Researchers in Cambridge grew these embryoids to the equivalent of 14 days old in 2025.
Which is right up against that established 14-day limit for research on actual embryos.
Exactly. So it forces us to ask, what is an embryo now? Does the 14-day rule still make sense? What research is okay? It reopens all those debates.
And then technology we interact with daily, like AI surveillance.
A perfect example, the EU AI Act, passed June 2024. It explicitly bans real-time biometric tracking like facial recognition in public spaces because they deemed the risk to civil liberties, privacy, freedom of movement unacceptable.
So it wasn't about whether the tech worked, but about its potential impact on fundamental rights.
Precisely. It connects directly to that point from the source material. Data illuminate consequences, but the threshold where can becomes should rests on cultural and philosophical ground.
That's such a key quote. Science gives us the can, but society, culture, philosophy, they determine the should.
Which highlights that we're often dealing with different kinds of truth, aren't we?
How do you mean?
Well, the article distinguishes between natural laws like gravity.
Things that just are, based on observation.
Right. Empirical regularities, they exist whether we agree on them or not. And then human rights, like privacy.
Which are based on agreement, values.
Exactly. Collective moral agreement. They need institutions, laws, enforcement to even exist.
And they can change, right? Natural laws don't change based on opinion polls.
Precisely. Natural laws get updated with new data. Human rights evolve through debate, democratic processes, shifting values.
So understanding that difference is key. We can't just expect science to solve ethical debates.
No, they operate on different principles, different ontological levels, you could say.
Okay, so if science alone doesn't set the ethical lines, who does? It sounds like a messy, multi-layered process.
It really is. The article points out oversight happening at all sorts of levels.
Like within the lab itself.
Yep. You have institutional review boards, IRBs. They're now starting to flag things like AI tools for designing molecules as potential dual-use research of concern, or DURC.
So internal checks within the scientific community.
Right. And then at the professional level, journals, for instance. Science updated its policy in 2024,
What did they add?
requiring authors of gene editing papers to share their code, and crucially, to include a statement about how they're mitigating any potential dual-use risks.
Self-regulation by the scientific publishing world.
Then you move up to the national level.
Government stepping in.
Exactly. You see places like Colorado planning its 2026 AI Act, requiring bias audits for high-risk AI.
Which might be different from other U.S. states or from the EU's approach.
Right. The U.S. is more fragmented, while the EU went for one big law. It shows different political systems grappling with the same ethical tech challenges.
And then there's the global level, too.
Absolutely. Think UNESCO and the WHO forming a joint task force on editing the human germline that launched early 2025.
Trying to set international standards.
Yes. Or COSPAR, the Committee on Space Research, setting the rules for containing those Mars samples we talked about.
Yeah.
International coordination for shared risks and benefits.
Wow, okay. So it's labs, journals, governments, international bodies, all drawing lines somewhere.
It's a complex web.
The article also gives these quick case capsules, right? Specific examples to chew on.
Yeah, they're great illustrations of the tensions, like the whole LK99 frenzy.
The room temperature superconductor thing kind of fizzled.
Right. The ethical angle there was open science versus reputational harm. Findings were shared super fast, live streamed even, before proper peer review.
And when it didn't pan out, it maybe hurt credibility.
Potentially. So the question raised is, should preprints come with a public communication code of conduct? How do we balance speed with responsibility?
Interesting question. Then there's the COVAX gap again.
Yeah, the capsule frames it as nationalism versus cosmopolitan duty.
Meaning, do nations look after their own first, or do they have a global obligation?
The pointed question is, do richer nations owe a moral debt or merely enlightened self-interest regarding vaccine equity? It forces you to think about the basis of global aid.
And the last one, AI and biothreats.
The core conflict there is publication freedom versus censorship, essentially.
Can we talk openly about how AI could be misused for bioweapons without actually helping bad actors?
That's the dilemma. The question is, can red team results testing vulnerabilities be shared without giving bad actors a manual? It's a classic information hazard problem.
These cases really bring the abstract ideas down to earth.
They do.
And it all seems to circle back to the main point. You can't really be a competent scientist today without also thinking ethically.
That's the conclusion the article really drives home. Technical skill isn't enough anymore. Things like CRISPR, AI, Mars sample return, they demand ethical foresight.
So what should we, or scientists, or just engaged citizens, be asking?
The article suggests 3 core questions we should habitually ask. First, whose interests are actually shaping the research agenda?
Okay, who benefits from asking this question?
Second, which moral theories are being used to justify or maybe challenge the methods being used?
What's the ethical rationale?
And third, critically, how will the benefits and the risks be shared? Not just now, but across borders and even across generations.
Those are big questions.
They are. But keeping them alive, asking them constantly, is how we navigate this. It lets us celebrate discovery and be responsible stewards of the immense power science gives us.
Especially in a world as connected as ours.
Couldn't be more true. It's about realizing science isn't in a bubble. Every choice has ripples.
So the big takeaway for you listening is really grasping this deep, tangled relationship between making scientific progress and thinking through the ethics. They go hand in hand.
Yeah, they're not separate subjects. And this kind of ethical literacy, it's not just for the scientists in white coats. It's for everyone trying to understand how these advances are reshaping our world.
Absolutely. Okay, so to leave you with something to mull over.
A final provocative thought.
Exactly. Think about a scientific frontier you see emerging. Maybe it's advanced brain-computer interfaces, or maybe something like weather modification tech, or, I don't know, synthetic biology, creating entirely new organisms. Something that isn't yet embroiled in huge public ethical debate.
Okay, go in mind.
What potential ethical frictions might pop up as that field develops and starts being applied? Use some of the ideas we talked about: fairness, access, dual use, colliding with norms. Who gets to decide? Where might the sparks fly?
That's a good exercise. Applying the framework to what's next.
Give it some thought. Thanks for taking this deep dive with us today.
Yeah, great discussion. Until next time.